I wanted to find a distance between 2 points that are on a specific line. The distance, if this was just the x line here, and the distance between 1 and 4, I would just subtract them. So I would do 4 minus 1, and the distance between those would be 3. But this is only working with the x line. And the same holds true if I was on the y line. This would be 1 to 5. I would just subtract 5 minus 1. And then looking only at a y line, this line segment, the midpoint would be 4. But when I have a diagonal line and the 2 points have both an x and a y, I'm going to pick the point with the bigger x to be the one that's to the right would be x2, y2. And over here, I'm going to call this one x1 and y1. Once I have that, I use the distance formula. So we'll start off with just a blank distance formula. And what I want to do is I want to find x2 minus x1. I'm going to square that, and I'm going to add to that y2 minus y1. And I square that. Substituting the values in, since I've labeled them over here, I'm going to start with x2, so that's 14. Minus x1 is 2. And then I plug in my y1 and y2, so my y2 first is 10 minus, and then here I have a 5, and I square that also. So I'm going to have 14 minus 2 is 12 squared. And 10 minus 5 is going to be 5 squared. This will give me 144 plus 5 squared is 25. And when I add those together inside the radical, I get 169. And the square root of 169 is 13. So the distance between these 2 points is 13 units. Now, if you want to find the actual point, the x and y coordinates of this midpoint, we'll do that in another video. At the end, you'll see a link to go to that video. Let's try another problem. So here we have a line segment, and the endpoints are minus 3 comma 10 and 4 minus 14, and I want to find the distance between those 2 points. So I'm going to find the distance using the distance formula. So I have x2 minus x1 squared plus y2 minus y1 squared. Get into the habit of writing the formula over and over again. This would help you to memorize it. Next line, I'm going to substitute in the values. Now, before I go into substitution, I want to label which one of these is x1, x1, y1, and x2, y2. The one with the bigger x is going to be the x2 point and y2. And then over here you have x1 and y1. So substituting in, x2 is 4, minus, and then you have a minus 3 for x1. So that turns that into plus 3. And then I have y2, which is minus 14, minus y1, which is 10. So I'm subtracting a positive 10. And then I have the square root of 7 squared plus, I have minus 24 squared, gives me 576. Whether it was positive or negative, it would still be 576. So I have 49 plus 576. And adding these together, I will get the square root of 625. And the square root of 625 is 25. So these are 25 units apart. This question is going to be asking, are these the vertices of a right triangle? In order to do that, I need to find the lengths of each of the sides, and then I have to use the Pythagorean theorem to tell me if this is a right triangle or not. So I'll just for the sake of speed, I'll just move really fast. So x2 is 5, minus x1 is 2, and y2 is 7, minus x1 is 1. So then I'm going to get on the next line, 5 minus 2 is 3 squared, so this is 9. And 7 minus 1 is 6, so 6 squared is 36. So the answer here, this would be 40 square root of 45. So I'm going to put square root of 45 over here. So this one is going to remain x2 because the x value is greater than the x value over here. I'm finding the distance between these 2 points, which is going to give me the length here. So I have x2 is 5 minus x1 is 4, and y2 is 7 minus y1, which is 0. So this is going to give me 1 squared and 7 squared. So this one is going to be square root of 50. And for the final side over here, this is going to be my x2 because it's to the right. So this is x2, y2. And this is x1 and y1. So using the distance formula, I want to do 4 minus 2 squared plus 0 minus 1 squared. So I'm going to get 4 minus 2 is 2, 2 squared is 4, plus, and then I have minus 1 squared, which is just going to be 1, so I have the square root of 5. And this side over here is the square root of 5. The Pythagorean theorem states that a squared plus b squared equals c squared. Well, I need, this is the hypotenuse is going to be equal to c. And it doesn't matter which of the 2 legs I make, so I'm going to make this one a and this one b. So I have a squared. When I square this, I get 45. Plus b squared, I just get 5, equals c squared, which is 50. And since 50 does in fact equal 50, the Pythagorean theorem states that this must be a right triangle. If I have a circle and the center of the circle is at 1, 1, and one of the points that's on the circle itself on the circumference is minus 1, 5, I'm able to find either the area or the circumference of the circle. We'll find both by simply finding what the length of this radius is. So let's draw the radius in here real quick. I need to find the length of that line, so it's the distance between these 2 points. So I start off with the square root, and I want to find the distance between the x's, square it, and add to that the distance between the y's. I square that too. I need to identify which is going to be x1 and y1, and which is x2 and y2. Well, the x that's to the right is going to be the x2 point, and that makes this one y2. And then this one over here is x1 and y1. Now having the points labeled, I can go and substitute. So x2 is 1 minus x1, which is minus 1. So now I'm adding 1. And then y2 is 1 minus y1, which is plus 5. So I have 1 plus 1 squared, which is 4. So I have 1 minus 5. This is going to be minus 4, and minus 4 squared is 16. I get the square root of 20. So the length of my radius here is going to be the square root of 20. So knowing the length of this line is the square root of 20, I can just simply plug that in over here. So I'm going to have pi times the radius squared. So the square root of 20 squared is 20. Proper form is to put the 20 in front. So this one is 20 pi. Now, this answer is acceptable. If you need to convert it, you just multiply by pi on a calculator, or 3.1415. And then for the circumference, we're going to have 2 times pi times the radius, which is the square root of 20. Now this is going to need some simplification, so I'm going to put the pi at the end. And then I have 2 times the square root of 20, which is the square root of 4 times the square root of 5. So I have 2 times, I'm going to pull out the square root of 4, which is 2, and leave the square root of 5 inside. So this becomes 4 square root of pi, 5 times pi. So this here is equal to about 30.5. So this is just units, and this one over here, I didn't put units squared.